Good day everyone, my name is Wal Christian Biwala together with Mardian Kutab, and we're here to present pressure sensor. What is a pressure sensor? A pressure sensor is an instrument consisting of a pressure sensitive element to determine the actual pressure applied to the sensor using different working principles and some components to convert this information into an output signal. A pressure sensor works by converting pressure into an analog electrical signal. We commonly measure the pressure of liquids, air, and other gases, amongst other things. The standard unit for pressure is the Pascal. This is equivalent to 1 Newton per meter squared. A pressure sensor simply monitors this pressure and can display it in one of the several units known around the world. This is commonly the Pascal, bar, and PSI or pounds per square inch in the United States. This is how a pressure works. The pressure of the air in your tire is a great example of pressure and how it is measured. As we air the tire up, the force it exerts on the tire increases, causing the tire to inflate. This is monitored with a pressure sensor inside the tire or on newer vehicles. Where can pressure sensors be used? Pressure sensors are used for many automotive, medical, industrial, consumer, and building devices, which depend on accurate and stable pressure measurements in order to operate reliably. How does a pressure sensor work? So, in a nutshell, it converts the pressure to a small electrical signal that is transmitted and displayed. These are also commonly called pressure transmitters. Because of this, two common signals that are used is a 4 to 20 milliamp signal and a 0 to 5 volt signal. Most pressure sensors work off of the piezoelectric effect. This is when a material creates an electric charge in response to stress. This stress is usually pressure but can be twisting, bending, or vibrations. The pressure sensor detects the pressure and can determine the amount of pressure by measuring the electric charge. Pressure sensors need to be calibrated so it knows what voltage or milliamp signal corresponds to what pressure. This is a basic zero and span calibration, or minimum and maximum, which is a common job for maintenance personnel. Why do pressure sensors fail? Pressure sensors typically die in the field because of mechanical damage, electrical overload like lightning or misconnection during inspections or repair work, or most commonly damage by overpressure, pressure spikes, or ingress of moisture or chemicals into the product. A pressure sensor is a device equipped with a pressure-sensitive element that measures the pressure of a gas or a liquid against a diaphragm made of stainless steel, silicon, etc., and converts the measured value into an electrical signal as an output. Pressure sensor accuracy. Sensor accuracy is comprised of two error modes, nonlinearity and hysteresis. Ideally, pressure sensors are perfectly linear. The output signal or reading is directly proportional to the applied pressure. Because sensors are mechanical devices, however, they are not perfectly linear, and this error is called nonlinearity. Nonlinearity is determined by the 5-point calibration method. A pressure standard, a device known to be at least 5 times more accurate than a pressure sensor, is used to apply pressures at 0%, 50%, 100%, 50%, and 0% of the sensor's full scale. A best fit straight line is fitted to these points, and the maximum deviation of any of the 5 points from the value predicted by the best fit line is defined as the nonlinearity error. This is an example of nonlinearity error. Common types of pressure sensor. Pressure sensors can be categorized according to the method they sense pressure changes. Sensors can observe and measure various physical reactions. Some of the most common types of pressure sensors are listed below. The first common type of the pressure sensor is gauge pressure. The second is absolute pressure, and the third one is differential pressure.
Gauge pressure. Gauge pressure is the pressure measured relative to the ambient atmospheric pressure. Gauge pressure can be measured using a diaphragm sensor, where one side of the diaphragm is exposed to the pressure media that is to be measured, while the other side is exposed to the ambient atmospheric pressure. So, absolute pressure. The definition of absolute pressure is the pressure of having no matter inside space, or a perfect vacuum. Measurements taken in absolute pressure use this absolute zero as the reference point. The best example of an absolute reference pressure is the measurement of barometric pressure. Differential pressure. The difference between two pressures, a pressure being measured and a reference pressure. This image is an example of a differential pressure. Um, from the right side, from the left side, it is 33 psi. Muna siya ang pressure being measured. Like pasulod pa siya sa kuan. Ang iyang pressure is gina-measure pa siya sa atong differential pressure. While in the right side, going to the right side, kaning sa niagi na siya sa kuan sa sensor, like ni 26 psi na lang siya kay tungod ni travel na siya or medyo ni calm na ang kuan pressure na ang pressure na nagkuan para mo push back sa water or the pressure, or simply as mo ni siya ang nakuan siya na measured na for the reference pressure. So, pressure sensor applications. Automotive applications. In automobiles, hydraulic brakes are a crucial component in passenger safety. The ability to control a vehicle using brakes is down to a complex blend of components, including pressure sensors. This can be used to monitor pressure within the chambers of the braking system, alerting drivers and engine management systems alike if pressures are too low to be effective. If pressure inside chambers is not measured, systems can fail without the driver knowing and lead to a sudden loss of braking efficiency and accidents. Until recently, airbags were solely designed to inflate inside vehicles for the front two passenger seats in the event of a collision. Now, car manufacturers have created airbags innovation inside and outside of vehicles that release faster, resulting in safer outcomes for passengers in any seat and pedestrian too. They have also found way of making the driving experience safer for the planet, bringing down engine emissions by recirculating exhaust gases. So, so a life-saving medical applications. So, ang kanso ng pressure sensor is magamit mo siya sa mga medical sa hospital. Raising the air pressure in a sealed chamber containing a patient is known as hyperbaric therapy. It can be effective for treating a number of medical conditions, from skin grafts, burn injuries, and carbon monoxide poisoning to decompression sickness experienced by divers. Measuring blood pressures correctly is crucial to patient care, as errors in the reading can lead to a misdiagnosis. Thanks to the recent innovation, Tiny pressure sensors can be implanted into the body, known as in vivo blood pressure sensing for more accurate monitoring. Also in automated building applications, as building and home automation technologies become increasingly popular, pressure sensors continue to play a central role in controlling the environments we live in. Refrigeration systems are one such example. Common coolant in HVACs like ammonia can cause significant danger to people in the event of a leak. Using a relative pressure sensors to monitor the pressure of the ammonia as it passes through the system ensure it stays within safe limits. Controlling large building environments is a challenge for designers and operations staff alike. Life enhancing consumer application. The things we use, carry, and wear on a daily basis are growing in intelligence. Adding a pressure Adding a pressure sensor to a customer device can provide new information for an improved user experience. Take a vacuum cleaners, or example, by measuring suction changes, they can detect what kind of flooring is being cleaned and adjust settings accordingly, or notify their owners when a filter needs replacing. Um, Industrial applications. So, submersible pressure sensors can be used to measure liquid pressures up to 30 psi, whether either a voltage or a current 4 to 20 milliamperes output in liquid tanks. By positioning these sensors to the bottom of the tank, you can get an accurate reading of contents in order to alert workers or the process control system when levels in the tank fall below safe limits. So, here's an example of advantage and disadvantage of a sensor. Advantages: so simple to construct, low cost and high durability, good resistance to shock, vibration, and dynamic pressure changes. Circuits are very simple and enable high resolution measurement, linear output, and millisecond response time. Operate at higher temperatures. Disadvantages: sensitivity to lower electrostatic discharge or ESD voltages. High cost due to lower manufacturing volumes. And last, here is here is our example of our explanation about on our report in the sensors pressure sensor.
Welcome back, and thank you for checking out this latest video brought to you by RealPars. If you're watching this video, then you're probably wondering what exactly is a pressure sensor. Today, we will hopefully cover all of the questions you may have about pressure sensors. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. To understand pressure sensors, first, you need to understand pressure. Pressure is an expression of force exerted on a surface per unit area. We commonly measure the pressure of liquids, air, and other gases, amongst other things. The standard unit for pressure is the Pascal. This is equivalent to 1 Newton per meter squared. A pressure sensor simply monitors this pressure and can display it in one of the several units known around the world. This is commonly the Pascal, bar, and PSI, or pounds per square inch in the United States. The pressure of the air in your tire is a great example of pressure and how it's measured. As we air the tire up, the force it exerts on the tire increases, causing the tire to inflate. This is monitored with a pressure sensor inside the tire on newer vehicles. So how does a pressure sensor work? In a nutshell, it converts the pressure to a small electrical signal that is transmitted and displayed. These are also commonly called pressure transmitters because of this. Two common signals that are used is a 4 to 20 milliamp signal and a 0 to 5 volt signal. Most pressure sensors work off of the piezoelectric effect. This is when a material creates an electric charge in response to stress. The stress is usually pressure, but can be twisting, bending, or vibrations. The pressure sensor detects the pressure and can determine the amount of pressure by measuring the electric charge. Pressure sensors need to be calibrated so it knows what voltage or milliamp signal corresponds to what pressure. This is a basic zero and span calibration, or minimum and maximum, which is a common job for maintenance personnel. In the RealPARS video, What is Sensor Calibration and Why is it Important?, we describe the sensor calibration in detail. What are some of the common types of pressure that you can measure with a pressure sensor? There are three common types that we use in the industry. First being gauge pressure. This is measured in reference to atmospheric pressure, which is typically 14.7 psi. You will show a positive pressure when it is above atmospheric pressure, and a negative when it is below atmospheric pressure. The next type is absolute pressure. Simply put, this is the pressure as measured against absolute vacuum. A full vacuum will have an absolute pressure of 0 psia and increase from there. If you need to read a pressure that is lower than atmospheric pressure, this is the type of sensor you would use. The last type that is commonly monitored in the industry is differential pressure. This is exactly what it sounds like, the difference between two pressures, a pressure being measured and a reference pressure. In industry, pressure sensors are used for a wide variety of processes. Some common uses are to measure the pressure of steam. Steam is commonly used to heat many processes in manufacturing facilities. This pressure sensor on the steam system can serve multiple purposes though. First and most obvious is to observe and monitor the pressure. Another purpose is to control when and where steam can flow and regulate its pressure. Steam can build up a pressure in a vessel and become dangerous. We can use the pressure sensor as an input device to open and close a control valve to keep the pressure and steam flow regulated. This only requires simple programming in the PLC to achieve this. Pressure sensors are also installed next to filters in many industrial processes. If the filter begins to clog, the flow will decrease. As the flow of the liquid decreases, pressure can increase or decrease depending on which side of the filter is monitored. If you monitor the pressure, it will give you a simple indication that the filter is clogged and needs to be cleaned or replaced. A common use that isn't as obvious is the use of a pressure sensor as a level sensor. In an open tank, you can use the hydrostatic pressure that is measured at the sensor. With a little math, using the size of the tank and specific gravity of the liquid, we can determine how much of that liquid is in the tank. If the tank is closed, it isn't as simple of an installation. It is still a viable option though. This will require at least two sensors to measure differential pressure. The high pressure sensor would be located at the bottom of the tank, measuring the liquid pressure, and the low pressure sensor near the top, measuring the air pressure inside. A calculation can then be performed to figure out how much liquid is in the tank. Let's take a look back at what we have learned. Pressure is an expression of force exerted on a surface per unit area. The standard units are the Pascal, bar, and PSI, or pounds per square inch. Pressure sensors convert the pressure into an electrical signal that can be transmitted and displayed. This is why many sensors are referred to as transmitters. These sensors commonly measure gauge pressure, absolute pressure, and differential pressure. Gauge pressure is measured against the atmospheric pressure. Absolute is measured against a vacuum. And the differential pressure is the difference between two pressures. Pressure sensors are commonly used to monitor pressures in different processes. A common thing to monitor is steam pressure. That pressure sensor can be used to control a valve to keep steam pressure at a constant level. Another common but lesser known use is to monitor the level of a liquid in a tank. Filter clogs are a common use of differential pressure monitoring. By knowing the pressure before and after the filter, you can determine if it is clogged. Thanks for watching another RealPARS video. I hope you learned about pressure sensors. Check back soon to find out how to choose a pressure transmitter. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to RealPARS.